K nearest neighbors. One of the most simplest algorithm, or simply KNN, most simplest in supervised, that is used classification and regression predominantly in predominantly used in classification. Also used as missing value imputation, KNN imputer. It's there in Python. KNN was one of the first statistical algorithm used to impute missing values. It is one of the simplistic algorithm which is available in machine learning or data science. KNN algorithm uses distance-based calculations. KNN is based on distance calculations, Euclidean distance, for calculating and assigning to the smallest, assuming. So what the algorithm says is, if the distance is closest between the particular predictive observation and the real-time data, then the new observation can be classified into that particular class or category. It assumes similarity. Shorter the distance, simply saying shorter the distance. So it's a distance-based algorithm which is used in data science, and it uses distance calculations, Euclidean distance. Shorter the distance, similar the class. Similarity is what it takes, and it calculates similarity based on there are many distance formulas. There are many types of distances. There are many distance measures which are used in KNN. The most popular is Euclidean, city block, cosine, correlation, Minkowski is also there, Manhattan, Minkowski, we'll use this one. So Euclidean, Manhattan, Minkowski, and then we also have, we'll use Hamming. Hamming is used in text. So Hamming distance is used in text, and cosine, correlation, they're all there, which are used in here. So these are the basic distance calculations that are used. Default is Euclidean. Is an integer which represents the number of, K is an integer which represents the number of, K value has to be, as there is no fixed to identify. So K means KNN, the K represents an integer value. K means the number of neighbors to be considered. Okay, so when you look at this K calculation, there is no fixed formula to identify what should be the exact value of K. It has to be done on trial and basis or grid search. We use grid search algorithm for doing the identification of K. So KNN algorithm diagram suggests, so as you can see from this diagram, so we are given a new data called question mark to be classified either into stars or class A and class B. Let's assume the K is 5. Sorry, K is 3. So it will calculate the distance between the closest, I think here it is K is equal to 6. So 1, 2, 3, 4, 5, 6. K is equal to 6. It identifies the closest 6 observations and calculates the distance. Then, K is equal to 3 only. K is equal to 3 only. 3 on this side, 3 on this side. It identifies the 3 closest observations on both the sides and calculates the distance. And it draws the circle. Now, in this circle, 2 greens and 1 star. Majority voting. So, the final prediction of question mark will be, right? So, this is how the algorithm works. So, it calculates the distance, predicted value, and the closest neighbors, and it uses majority voting to identify the majority class and assign the majority class to the predicted observation. In case of regression, it is average. In case of regression, it will take the average of the closest values. So this is the process it will follow in terms of the KNN algorithm. Before implementing the KNN algorithm must be done, you have to do scaling before we implement the algorithm, particularly on the numeric independent, either standard scalar or min-max, either the standard scalar or the min-max scalar must be. KNN algorithm is also referred as lazy algorithm as it will not start calculating a predictive observation is given. It simply the historical data and calculates only when. So in all our algorithms, prior calculations are done. In our other thing, prior calculations are done and prior outputs are stored in our data. But in this case, it doesn't happen. It does not start calculating until it is given a predictive observations. Till that point, it simply stores the data in its. Whereas in other algorithms, once you give the training data, they start calculating, they calculate various metrics, and then they store the outputs as an equation or as a picture, or as a diagram like a tree, or in case of neighbors, the probability tables, all will be stored. And then once the observation is given, they use those outputs to predict. But in this case, it doesn't happen like that. Only once you give something to be predicted, then only calculation process will start. Till that time, it will just store the, all right. So that is why it is referred to as lazy algorithm. KNN is a non-parametric algorithm. No assumptions. It's a non-parametric algorithm. There are no assumptions. Tree-based models like decision tree is also a non-parametric algorithm. All the tree-based models are non-parametric algorithm. Similar is the case with KNN. It's a non-parametric algorithm. There are no assumptions that to be made for this algorithm. Now the K value has to be K value if it is will lead to, if it is large, calculations to be done. So it has to be for appropriate. So the K value cannot be smaller. If it is too small, then it will create to noise in the model. Noisy model means not a good fit model. The model accuracies or the model RMSEs will be not good. If you do K is equal to large, there will be too many calculations involved. So it will lead to little bit of computing power problems. So to avoid this, you have to find the optimal K for an appropriate model. And for finding the appropriate K, we use grid search algorithms. Grid search algorithms models with given parameters identify the best fit. So it will give, you can give different parameters to the model, and it builds models for all the parameters. It builds models for all the parameters, and thereby it will identify the best fit model. It identifies the parameters, it builds models for the different parameters given and identifies the best fit model. That process we call it as grid search. So we will implement the grid search and we'll try to find the best fit model. So KNN works with large scale data as well as smaller data. It works with any type of data like tree-based models. They work with any type of data. See, typically non-parametric algorithms, they work with any type of data, whether it is a large data or it works well with outliers in the independent variables, because we are doing scaling, right? Scaling will take care of the outliers and skewness problems in the independent variables. So that way, if the independent variables has too much of skewness and too many outliers, then KNN is one of the best algorithm, because as part of the process, we need to scale. Once you scale the data, you will reduce the outliers and you will also reduce the. So when your independent variables have many trouble of skewness and outliers, then this is a better algorithm, because scaling is compulsory on numerical variables. You should not scale the categorical variables or dummy encoded variables, right? So scaling should not be implemented on dummy encoded variables. All right. So this is the theoretical background of KNN, K nearest neighbors algorithm, one of the simplest algorithm in, and default distance calculation in R and Python is Euclidean. You have option of changing it to Minkowski, Manhattan, and all the distances are there in both R, Python, SAS, or any software. Even Mahalanobis is also there. Cosine is there. Cosine we use in recommender systems. Recommender system means based on what you are viewing, YouTube will give you recommendations, right? In Netflix also, whatever you are viewing, you will get a lot of recommendations based on the similarity. Or in Amazon, if you are viewing a product, you will get a lot of similar product recommendations. That recommendation systems is also based on distance calculation. There we use cosine. Cosine is a very popular similarity algorithm. It is also based on distance only, cosine similarity or cosine distance. Or you can also use correlation and covariance, which finds similarity between two variables. So cosine is widely used in recommender systems, recommendation systems. We'll work on recommender systems on large scale recommender data, or movie recommendations, or Netflix recommendations, Amazon product recommendations, Google search recommendations, wherever you have recommendation as part of the output, there cosine is popularly used. Nowadays, the new metrics are also developed, which are also being experimented, but predominantly cosine is preferred, cosine similarity. And the formula for cosine similarity is this. So cosine similarity between A and B is equal to cos theta is equal to A into B divided by magnitude of A divided by magnitude of, what is magnitude? Square root of x1 square plus x2 square plus x3 square till xn square, or square root of y1 square plus y2 square plus y. That is your magnitude calculation. So cosine similarity is similarity between two vectors. Okay. A into B divided by magnitude of A multiplied by magnitude of B. Cosine similarity. So this is the theoretical background of KNN algorithm. So the right value of K is very important in this thing. The success or failure of the model depends on the right value of K, or the appropriate value of K. So it cannot be too small or it cannot be too large. So generally what we have to do is you have to give a range of Ks and build multiple models and identify the model that has the best or best fit performance. Typically, we don't go beyond 20. In range, we give 25. K is equal to 1 to 25. So it will build all the models with K is equal to 1, K is equal to 2, K is equal to 3, like that. It will build multiple models and it identifies the model that has the highest accuracy or lowest RMSE. Like in random forest and gradient boosting, we don't have a method to identify the exact number of trees required. That is also done by trial and error or grid search. Similarly, wherever you have the K in statistics, that has to be an integer. K means clustering algorithm also. The K value, you have to come up with a value of K based on grid search or trial and error. Okay, we can't go with it, but by default in all softwares, K will be 5. By default, K value will be 5. Because as per the lot of experience, most of the times it will be K is equal to 5, even if you do it. So K, they kept it as default is K is equal to 5, but it depends on your data, how many rows you have, how many variables you have in your data. Okay, based on that, it will identify the appropriate value of K. KNN is used when all your variables are numerical. KNN doesn't work on categorical data. So if you look at the KNN imputer in Python, they have clearly mentioned it. KNN imputer can work only on numerical data. No. Independent variables being numerical. So default is 5 neighbors, because you can't calculate this distance with categorical variables, right? Distance can be calculated only between numerical points. Categorical, again, you have to go with Hamming distance. That's a different distance method. So here, weights are uniform, metric is Euclidean. You can see here, right? Default is 5 neighbors, KNN imputer. Weights is uniform. You treat all the observations with uniform weights, and then NaN is Euclidean. Now, weights is another metric. Uniform weight means all points are weighted equally. All the points in the neighborhood are treated equally. Now, if you give weight is equal to distance, it will take the inverse of the distance. So closest neighbors will have more influence than the farther neighbors. So uniform is by default, because you have to treat all the neighbors equally. That is what it is did. NaN is equal to Euclidean means it uses Euclidean distance. If you want, you can give other matrix also. NaN underscore what to call Minkowski, NaN underscore Manhattan, like that. You can give the other arguments also. Okay, KNN imputer works only with numerical data, because distance can be calculated only on numerical data points. For categorical data points, we have to use Hamming distance. Hamming distance is like this: absolute x minus y, x is equal to y is equal to d is equal to 0. Distance is 0 means it will be male. Distance is equal to 1 means it will be female. So Hamming distance is what we have to use on categorical data. If you are looking at Hamming distance calculation, so it compares every letter of the strings based purely on, so you are trying to find distance between A, B, C, D, E, F, G to B, C, D, E, F, G, H. A and B, are these two are equal? B and C not equal. C and D not equal. If they are equal, it is 0. If they are not equal, it will be 1. So the distance is right? Because not equal, right? String 1 and string 2, there is no equality. If it is equal, then it becomes, if it is not equal, it becomes, and then you sum total the values, you will get the distance as 7 here, because none of them are equal. That is what in the formula sheet also said. X is equal to y, 0. X is not equal to y, 1. Similarly, we have other distance measures also. Levenstein distance. So number of operations needed to convert one string into another. Here, A, B, C, D, E, F, and B, sorry, A, B, C, D, F, G, A, B, C, D, F, G. Here we are deleting A and we are also removing D. So two steps are equal, then it becomes step 1, delete A. Step 2, add H. Two operations are done, right? For making A, B, C, D, F, D, H to B, C, D, F, E, H, what you have to do? First, you have to delete A from the string, and in the second step, you have to add H to the string. Two operations are done, one deletion and one addition. So the Levenstein distance is 2. Cosine, like I told you, distance between two vectors in the document. So I love going to the movies, I love going to the work. If you remove the duplicates to the movies, work, y is always rating when, so when you make the vector of each document, then we will calculate the cosine similarity. So cosine similarity is very popular when you have large scale text. When you have data in sentences, cosine similarity is there. I will talk about cosine similarity when we do recommender systems. Recommender systems, we will study them when we do build a model of based on NLP, natural language processing. That time I'll explain it. But in text, predominantly used is Hamming. X is equal to y is equal, X is equal to y is 0. X not equal to y is 1. Now let's get to the calculation. Click on the classification sheet. So here the two dependent variables are height and weight, t-shirt size. Find the t-shirt size 155 centimeters and weight 55 kgs. What is the t-shirt? If a person's height and weight is given, what should be the t-shirt size is what we have to find out. Okay. So on this data, we will implement standard scalar. Scalar is to be implemented. What is the formula for standard scalar? X minus mean divided by standard. So we need to calculate the average and standard deviation for the data. So is equal to average, open bracket, is equal to STDEV, open bracket, average and standard deviation for the observations. Right? I'll have to calculate the average and standard deviation. Now we have to scale. Height underscore, oh, we also have to scale this also. 155 minus divided by, okay, we'll do it later, not now. Sorry. So is equal to open bracket x minus mean. Now mean is constant, so Fn plus F1 divided by standard deviation. Again, standard deviation is constant, Fn plus x minus mean is equal to open bracket x minus mean. Mean is constant for all observations, so Fn plus F4, $2 signs will come, divided by standard deviation, Fn plus F4. Now you double click, it will calculate for all the observations. So this is the formula. X minus mean. Mean has to be fixed by pressing Fn plus F4 divided by standard deviation. Standard deviation has to be fixed by pressing Fn plus F4. Weight underscore is equal to open bracket x mean. Mean has to be fixed by pressing Fn plus F4 divided by standard deviation Fn plus F4. These predicted values also have to scale. 155 minus 164 standard deviation. 55 minus 62.33 divided by standard deviation. Now we will calculate the Euclidean distance. Is equal to square root of x2 minus x1 whole square, open bracket, y2 minus square, close bracket. Or we will do one thing. Is equal to SQRT, open two brackets, x2 minus x1 whole square plus open bracket y2 minus, now x2 and y2 are similar, so Fn F4, okay, x2 and y2 are common. We're calculating distance from those two common points, so you have to press Fn plus F4 for the absolute cell referencing. Then you double click the So this is the formula for calculating the Euclidean distance. X2 minus x1 whole square plus y2 minus y1 whole square. X2 and y2 are the values to be predicted. Select the Euclidean distance. Select the Euclidean distance values. Home tab, sort and filter, sort smallest to largest. Sort and filter, sort smallest to largest. Expand sort selection, sort. Now assume k is equal to 3. If it is k is equal to 3, these are the first three predictions. So the t set size will be, assume k is equal to 5. 1, 2, 3, 4, 5. Shortest distance, again it will be. So based on our assumption, we will get the scale. But before that, you have to sort the distance, smallest to, and all the other variables also have to change. So if I change 172 is the height, 69, and then if I sort the distance, smallest to largest, sort. Now it becomes, by changing the, what you call these things, it will change. Now it becomes large. So if it is 155, 55, it becomes, now this is standard scalar. Apply min-max scalar. So click on this, move or copy, create a copy. Right click on this, move or copy, create copy. Tick mark create copy, it will create a sheet. Now remove these things, delete all the values. Here you will use min-max. What is the formula? X minus x min divided by x min. So what you have to do basically, you have to calculate the minimum of the data and you have to calculate the maximum of the data and implement. Height underscore, weight underscore, create a copy of the sheet, delete all the calculated values, and then you calculate the min and max and implement the formula. See here, 160 and 63 if you take, k is equal to 3, 2L and 1M. K is equal to 5, 3M. If you take height as 160 and weight as 63. No? K is equal to 3. That's what it's your choice. If you want to take k is equal to 3, 2 L's and 1M. If you take k is equal to 5, 3M and 1L. That I'm telling you, it's a judgmental thing. There is no fixed rule for that. So that person has to experiment with both the sheets, and whichever fits he will take. Robust is also there, no? If there are many outliers, extreme outliers, so then you can use robust also. For regression also, do standard scalar. Okay, if you're done, you can take your break.
Is it necessary to do standard scalar for
Numeric
regression?
Yes. See, you have two options. You can do it, or if you don't do it, sometimes it gives you in the model saying that iterations are not, convergence warning will come. So once the convergence warning comes, you have two options. Either you scale the numeric variables or you increase the maximum iterations. So in the logistic regression, people generally don't do scaling because we have another option called max, increase the iterations. Max underscore iter, you can increase it to 1000 or 2000. So the convergence warning
in the class was you
3000. Yes. Anything above, because by default is 200. Convergence warning means all the coefficients were not calculated because either the data was or the iterations are not enough. If the data is too large, you have to scale it to the smaller levels using a standard scalar or increase the iterations. Give a model more iterations to compute and make the coefficients calculations easy. You have two options. You can scale or you can do max iterations. Generally, we use max iterations.
So if we not scalar and if we use max.
In logistic regression, the computation is very easy, right? Matrix calculations. Logistic regression and linear regression uses matrix formulations. Matrix formulations are less computational intensive compared to the derivatives and the calculus-based calculation. So matrix is a simple parallel computing process, right? So matrix calculations are faster. They don't require much of the computing power compared to the derivatives and the calculus, which require a lot of computing power. Either you do scaling or the model says convergence warning, it will only tell you either scale the data or you increase the iterations. In the error only you will get it. Pink color error comes, convergence warning, either scale the data or increase the iterations. Increase the iterations will be the best option.
You think the change if you don't do max iteration, changes won't be as accurate enough?
No, all the coefficients will not be calculated. That means some variables won't have coefficients. If you try to predict, it will give an error saying all coefficients are not calculated. You need all coefficients for all variables, right? Until then, you can't build a model. So the equation will not be complete. If convergence warning comes, that means coefficients for all the variables are not calculated. If coefficients for all variables are not calculated, you can't use it as an equation for prediction. Then it will, if you try to predict, it will say coefficients are not there. So you have to go back and make sure all the coefficients are calculated for all the variables in the model. So the easiest process will be increasing the maximum iterations. Sometimes you might have to go to 10,000 iterations also, but it will not be computationally intensive.
After that, then after will be good.
Direct only, they're non-parametric algorithms, na? They work with skewness and outliers. What is the point of scaling in trees? There is no need of scaling in trees because they are non-parametric algorithms. Why do you need to? Even if skewness and outliers are there, it doesn't affect the calculation of the decision tree because it uses standard variance reduction and regression, which is again a deviance based measure only.
So you said back then we use max iteration into 10,000, so that depends on the observation.
That depends on the number of observations and number of variables. If you give 2000 and it says still not enough, you have to keep on increasing till the point where you have the iterations equal.
So minimum is 2,000.
Now we can do 1000 also.
So
It's a random value. It's a random value. We can take the multiples of that random value if it is not fitting.
Sir, for start classifier, we use final estimate. I didn't understand that.
Comparative estimator has to be there, na? Baseline estimator has to be there.
Okay.
See, you need to have a comparative metric to compare all the models. That is the one. How will you decide if you don't have a comparative metric? How will you decide which model is performing well and how much deviation is there or not? So a base estimator has to be there.
We'll be comparing with the estimator.
Base estimator, and then it will be deciding the models.
Model names in estimator.
Yeah,
You will be comparing with this final estimator and
we will tell you which is the best fit estimate.
like we can do
Any final estimator, your
So
choice.
when I try to machine create game, then we have CLF model or.
Maybe that is the best fit model. You read the documentation, you will understand what it means. Clearly, it is given in the documentation.
The accuracy which we get, start classifier.
Hmm.
So like generally when we do like individually,
Hmm.
we make sure like check the cross validation score report, we again make some adjustment, iterators and everything.
Hmm.
So nothing is needed over here. like,
There you can do the same thing. You can print a classification report. You can do all those things. If you don't feel that stacking is not working, you have to go back to the individual models. If stacking is not giving you the right model, you have to go to the individual models and do it. Stacking is a process which is used in AutoML. When you have cloud computing and large scale computing available, you use it. Otherwise, you don't use it at all. The best practice is always individual model and comparison based on metrics. That is what industry guys want. They don't want to do AutoML. But since they have integrated it into Python, I just showed you the process. But AutoML is not encouraged. You have to go model by model with proper understanding of the data. So they will ask you why particular model is not fitting. You can't know in stack until you do an individual model.
So what is the difference between
Stochastic gradient descent.
yeah,
That's a descent algorithm we will study when we do neural networks. Gradient descent we already did, right? Minimizing the weights. It's an iterative weight adjustment algorithm. Stochastic gradient descent uses stochastic process.
Then they said with the method of SGR.
Stochastic gradient regression. See, generally we adjust the weights based on ordinary least square method. There is another method called SGD as well as MLE, maximum likelihood estimate also. Normally, generalized linear models, we call them as generalized linear models. The ones which I was talking about, SGR and MLE, we call them as generalized linear models. Now, industry is adapting to them. Some processes they are using it. So we will talk about it later. Generalized linear modeling, we will talk about it later. How regression, apart from OLS, there are other methodologies also. There's a Bayesian models also, which are being used in industry. So we call them as generalized linear models. We will discuss them later. We will try with 15. See, this is also trial and error only. So 70 fits, it is fitting, and you can check. It's just running, right? There's nothing harm in it. You should just be patient. It will run all the parameters. You give 50, 25, 30. It's only the matter of waiting till you get the output. That's all. So that is the advantage of grid search, and grid search runs a little bit faster. It's not that it will be very slow. Earlier it was slow, but now the one after the experimental one, which they have implemented, grid search CV with cross validation runs very fast. It all depends on your CPU. If your CPU is large enough, 8 GB and above, grid search CV would be a better option. for random forest, gradient motions, wherever you need to predict parameters. As we go forward in neural networks, the next algorithm we are going to discuss is neural networks. There we have to decide many parameters. What should be the learning rate? How many layers should be there? How many neurons per layer should be there? What should be your what you call regularization parameters? So lot of things are there where you have to guess parameters. Even in XGBoost, you have to give lot of parameters, right? When you don't know how to identify the exact number of parameters, give a list of parameters, run it on the grid set CV, you will get the best set of parameters, and you will finalize your model based on the best parameters. Now, only thing is you need to give this grid search time. If you give time to it, sometimes it may take for large data with many parameters in neural networks in the XGBoost 30 to 40 minutes also. Depends on the size of the data. And preferably, if your laptop is having less CPU, right away use Google Collaborate because they provide 13 GB RAM, right? So there it will be faster. So for parameter tuning, if your laptop is less than 8 GB, it would be suggestible to go with Google Collaborate. If you have 12 GB, then it works well. See, parameters is 13. Score has fallen down to 72.96. Neighbors is 13. So I think we can go up to 25 se zyada bhi ja sakte hain. We can go up to 40. N underscore neighbor. So you have to give it the final in your model, the N underscore neighbor value, right? That will be the best params. So see, here we have just given neighbors as parameter. You can also give uniform and distance. There, the other two metrics are there, na? Uniform parameter and distance parameter is also there. It's callable, we don't use. Callable means if you are creating your own code, your own function, that's all. So if you want to give uniform or distance, that also you can give. Okay. So you can give multiple parameters. So in this case, we can give only 2 parameters. But when you define XGBoost or neural networks, it will be 5 or 6 parameters. So the grid will be larger. Param grid will be larger. And the best params will give you for each parameter in the grid a value which is giving you the best fit model. So we will implement that also when we work on neural networks and all. We will try to implement that also. So I think we can further improve it. So I increase the range to 40. Let us see how much score will increase. Because 73 is what is there for 23 neighbors. So I think it might go up to 80. If it doesn't go, then we'll go back to the 23 neighbors. The score might increase, right? In decision tree and random forest. No, that we can't do that. So the scores you can, I think, let me see if I can check individual scores. I don't think we can check that scores. So here you can see here, KNN, N neighbors, 1, 10, 1, leaf size 20, 41, P is equal to 1, 2, weights, uniform distance, metric, Minkowski and Chebyshev. We by default is Euclidean, na? He has used Minkowski and Chebyshev, and then he has fitted the model. So you can see here, leaf size is 20, metric is Minkowski, number of neighbors is 10, P is equal to 1, weights is equal to uniform, best score is 0.835. So you will build the final model with that. So basically you can give multiple parameters. I gave how many? 35, 40. So 34, 74, slight increase in the model. So let us see if you can see the grid model. So you can see CV underscore results. Neighbors to 70 like that it will give. For each neighbor, what is the scores? See here. Okay. So CV underscore results will give you the each neighbor score. 34 is the maximum, 74. So for 35 onwards, I think it is reducing. See, it is reducing. So 74 is the highest, na? And then after that, it is reducing. 35, 36, 37, 38, it is reducing. So that is why 34 is the best option. You can see the CV results of the data. So you can see here. So for this model, neighbors is equal to 34 is the best fit model. So give 40 as the maximum neighbors. Some people just give 50 also. It's nothing wrong, right? It's only you have to have time. That's all. It's only patient. It will give you the best neighbor.
So who's a child matrix? So here when I plan this logical data is imbalanced. So how do I
You have to balance the data. That we will discuss later.
Okay.
You have to use an algorithm called SMORE to balance the data. And then the metrics will improve based on the best score. See, for any neighbor is equal to, starts from 1. For n neighbor is equal to 1, it is this. Neighbor 2, neighbor 3, neighbor 4, 5, 6, like that, it calculated for all models. Among these scores, the highest score is this, which is for neighbor 34. So that's why it decided neighbor 34 as the best fit. So whichever model has the highest accuracy, here it is score means accuracy. Here the score means accuracy. The model that has the highest accuracy will be the best fit model. 9 neighbors 34 has the highest accuracy of 0.7405. That is why it fits the neighbor as 34. That's what the imbalanced data, we have to look at sensitivity, specificity and all. Till there is no change in the accuracy, till the accuracy falls, till the point where accuracy starts falling, that will be your maximum point. So it is stopping at 34, no? After that it is falling. That's why it finds as 34. Till the point it goes and then it falls. The accuracy will fall. The point at which the maximum is the best neighbor.
If we give the range till 100 on.
I think it should be 34 only. You can try if you have time at home. It will stop. You can try 100 at home because it will take a lot of time. 8 GB. For all grid searches, 8 GB is the minimum. Or Google Collaboratory with 20 Mbps speed, minimum of 20. Because what is your processor, i5 or i7? i5 will only go up to 12 GB. After that, it will not support. It is waste. i7, 8 plus 8, 16 GB you can go. But i5 don't go beyond 12 GB because it is of, even if we increase it also, no point. So i5 maximum is 12 GB, 12th generation. i5 12th generation, it goes up to 12 GB. AMD, I'm not sure. You have to check with the store guy. Because I use i5 in my Windows laptop also, it's 12 GB RAM. Because after that, there is no point. I googled an internet and they said if it is i7 and above, i9 and i7, then you can go up to 16 GB then. But otherwise, 12 GB is max for i5. So already 8 GB RAM was there. So I added 4 GB extra when I was buying the laptop. There only he added that. It's a slot is there. You just put the slot and connect it. That's all. While buying only, I added it to 82 plus for 12 GB. Yes, 12 GB is enough. See, most of the data science problems, that's what Google Colab and Kaggle case also made it only 12 GB or beyond that point, you have to go for deep learning and more computing on it. Systems will take up to 12 to 13 GB only. Your laptops or PCs or desktops. If you want to go beyond that, it has to be on larger computing. I have, but right now I'm busy. I'll do it after 1 PM. I'll do it after 1 o'clock. Yeah. Right now I'm busy.